In the dry docks at Newport News shipbuilding, a massive wall of gray steel has taken shape. This ship is not just a vessel. It is a floating city. It is a nuclear-powered fortress. It is also a moving airbase that can bring war to a coastline in a matter of days. This ship is the USS John F. Kennedy, CVN 79. As the second carrier of the Gerald R. Ford class, the Kennedy carries more than just aircraft. She carries a legacy that feels even heavier than her 100,000-ton weight. Her name comes from the 35th President of the United States. John F. Kennedy is remembered for leadership during dangerous times, and also for his own service as a naval officer in the Pacific. His story is part of American military history, and while the name is powerful, the ship itself represents something even bigger. It marks a turning point in how the U.S. Navy plans to fight future wars. For nearly 50 years, the Nimitz-class aircraft carriers have ruled the oceans. They have been the symbol of American sea power since the 1970s. But the Navy is now moving away from these famous ships. It is building a new generation of supercarriers. These carriers are meant for an era of drones, robotic systems, directed energy weapons, and high-intensity conflict against advanced enemies. But this transition has been messy and controversial. The USS John F. Kennedy has faced major pressure from the start. Her cost is enormous, around $11.3 billion for the ship alone. That does not include the air wing, which can add another $5 to $7 billion. It also does not include the escort ships that make up the carrier strike group. On top of the cost, the program has suffered delays. It has also carried the shadow of technical problems seen on the first ship of the class, the USS Gerald R. Ford. So, as the Kennedy moves closer to joining the fleet, one question keeps coming back. Is this ship a necessary step forward for American power, or is it a very expensive symbol that could be made obsolete by modern missiles? To answer that, we need to look at why the Navy wanted this class in the first place. The Nimitz carriers were masterpieces for their time, but by the early 2000s, they were reaching hard limits. They were running out of electrical power. They were also reaching the limit of how much weight and equipment could safely be added without causing serious balance problems. Future weapons like high-powered radar systems and shipboard lasers demand huge energy. The Nimitz design simply does not have enough margin left to support what is coming next. The Ford-class carriers were designed as a fresh start. From the outside, the Kennedy still looks like an American supercarrier. The hull shape feels familiar, but inside, nearly everything is new. The Ford-class design is built around three main goals. First, it must launch more aircraft faster. Second, it must reduce manpower through automation to lower long-term operating costs. Third, it must be future-ready, with enough electrical power for weapons and systems that may not even exist yet. The heart of the Kennedy is her power plant. Earlier carriers used steam for almost everything. Steam drove the ship forward, powered catapults, and supported many ship systems. The Kennedy moves away from that old model. She is built around a far more electric design. This is made possible by two new Bechtel A1B nuclear reactors. These reactors are simpler in many ways, but they are also far more powerful than the A4W reactors used on the Nimitz-class. The most important point is electricity. The A1B reactors can generate around 250% more electrical power than the older design. Even more interesting, the Kennedy does not need all of that power right now. She uses only about half of what she can produce. The rest is a reserve. That reserve is not wasted. It is intentional. The Navy expects that in the 2030s and 2040s, ship defense will change. Instead of relying mainly on guns and missiles, future carriers may use solid-state lasers and high-powered microwave weapons to defend against incoming threats. Hypersonic missiles in particular will force new defensive solutions. Those energy weapons will need massive bursts of electricity. The Nimitz carriers cannot support that kind of demand. The Kennedy can. This electrical advantage makes it possible to replace one of the most famous systems in naval aviation, the steam catapult. For decades, launching jets meant high-pressure steam, loud noise, and violent force. Steam catapults are reliable, but they are heavy, brutal on aircraft, and hard to fine-tune. They hit the plane with a strong jolt at the start of launch, which puts heavy stress on the airframe. The Kennedy replaces steam with the Electromagnetic Aircraft Launch System, or EMALS. It works using a linear induction motor, similar to the technology used in maglev trains and advanced roller coasters. Instead of steam, EMALS uses a magnetic wave created by electricity. That wave pulls the launch carriage forward and accelerates the aircraft down the track. This gives the ship a key advantage: adjustable force. Steam has limited control. Emails is digital. The ship can precisely control how hard it launches each aircraft. It can fire a fully loaded FA-18 Super Hornet and then soon after launch a much lighter drone without damaging it. A steam catapult could destroy a small unmanned aircraft. Emails can launch it smoothly. This smoother acceleration also reduces stress on Navy jets, which helps extend aircraft service life. And because the ship no longer needs huge networks of steam pipes, it lowers internal heat, humidity, and maintenance work. Still, emails has been a major source of criticism. On the USS Gerald R. Ford, emails suffered reliability problems and software issues. Early in testing, failures could cause shutdowns and delays. But the Navy claims that thousands of launches have helped fix many of these problems. The Kennedy is also receiving updated and improved versions of the system. Launching aircraft is important, but recovering them is mandatory. A carrier that cannot bring aircraft back is useless. The Kennedy uses Advanced Arresting Gear, or AAG. Like emails, AAG replaces older systems with a more modern electric design. Older carriers used hydraulic systems. AAG uses electric motors and water turbines controlled by software. This allows better control of arresting forces and supports a wider range of aircraft types, including light drones. This matters because the future air wing will include systems like the MQ-25 Stingray unmanned tanker and possibly drone wingmen flying alongside crewed fighters. The real measure of a carrier in war is sortie generation rate. In simple terms, it means how many combat missions the ship can produce in a day. The Kennedy is designed to generate about 30% more sorties than a Nimitz carrier. That means more bombs dropped, more fighters on patrol, and more constant pressure against enemy defenses. This improvement comes from smarter design. The flight deck and internal layout were reworked for speed and efficiency. The island is smaller and moved about 140 feet further aft compared to older carriers. That opens more usable space on the deck. It creates better room for refueling and rearming aircraft. On older carriers, planes often had to cross busy areas and active launch paths to get serviced, creating traffic jams. On the Kennedy, the flow is designed like a pit lane. Jets land, move into open service areas, get refueled and armed quickly, and then taxi straight back to the catapult. Weapon movement is also faster thanks to advanced weapons elevators. Instead of old cables and pulleys, these elevators use electromagnetic motors. They can lift heavier loads, about 24,000 pounds instead of 10,500 pounds. They also move weapons more directly from storage magazines to the flight deck. That reduces delays and helps keep aircraft turning faster. Early versions of these elevators also caused problems on the Ford, but improvements were made, and the Navy expects the Kennedy to perform better. All of this leads back to the argument about cost. Critics say the ship is too expensive and too risky. They argue that a carrier worth over $11 billion could be threatened by missiles like China's DF-21D anti-ship ballistic missile. They also argue that the Navy should invest in more submarines or smaller ships instead of putting billions and thousands of sailors into one floating target. Supporters answer with long-term logic. The ship is expected to serve for 50 years. Automation reduces manpower. The Kennedy needs around 600 to 700 fewer sailors than a Nimitz carrier. Fewer sailors means lower cost over time. The Navy estimates that reduced crew size and lower maintenance could save around $4 billion across the ship's life. In that view, the high price up front is partly paid back through decades of savings. Supporters also argue that no other platform can do what a supercarrier can do. No other nation has a ship that can park near a coast and deliver constant air power at scale. A Ford-class carrier is not just a weapon. It is also a political and diplomatic tool. It is a moving message that can appear anywhere on the planet. The Kennedy also reflects lessons learned. The Ford was delivered with unfinished systems, causing years of additional shipyard work after delivery. For the Kennedy, the Navy used a different approach. It focused on making the ship more ready at commissioning. Shipbuilders also improved construction methods, using more modular building techniques to reduce man-hours and improve efficiency. One major change is radar. The Ford uses the expensive dual-band radar system. The Kennedy and later ships use the Enterprise Air Surveillance Radar, or EASR. This radar is connected to the SPY-6 family used on new destroyers. It is lighter, cheaper, and easier to maintain. It still offers excellent performance against aircraft and cruise missiles. This switch saved hundreds of millions of dollars and shows the Navy trying to control rising costs. So, why does the Navy want the Kennedy now? The answer points to the Indo-Pacific. China has launched its own new carrier, the Type 003 Fujian, and it also uses electromagnetic catapults. The technology gap is shrinking. The Navy believes it cannot rely on designs rooted in the 1970s. The Kennedy is built to deploy stealth aircraft like the F-35C deeper into contested zones. She is also meant to support future sixth-generation fighters. Her higher sortie rate allows her to put more pressure on enemy defenses. Her electrical reserve gives her a path to mount future laser weapons to defend against incoming missile threats. So, is the USS John F. Kennedy worth $11 billion? If the future only includes low-intensity wars and small insurgencies, then the answer may be no. You do not need a nuclear supercarrier to fight pickup trucks. But that is not what the ship is built for. The Kennedy is designed for a world where major powers could clash. It is designed for a future where satellites may be destroyed, air bases may be hit by missiles, and land infrastructure may be wiped out early in the war. In that kind of conflict, a mobile, nuclear-powered airfield with layered defenses may still be one of the most resilient tools of power projection. The Kennedy represents a hard and expensive shift. The move from steam to electromagnetic systems was always going to be painful. New technology always brings setbacks. But as the systems mature, the Kennedy could offer a level of capability that no other nation can match. She is sovereign American territory that can travel hundreds of miles per day. And when she finally deploys, she will not just patrol the oceans, she will patrol the future.